Hey everybody, welcome to our SAT office hour tonight. And we are going to be doing Desmos tactics today. But before we do that, let's go over our weekly challenge problems. So we had four this week. So if we take a look at this first one, we've got the equation of a circle, and they give us the diameter endpoints. And we want to know the value of a plus r. So one thing we should know is that the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. And notice that this is very similar. So all they're really doing is saying that number one, h and k are equal. They're both equal to a. So what we first want to do is find the center of the circle, which is HK. Well, we're going to get the center in a different way. We're not going to actually have our equation. The center is just the midpoint of the endpoints of the diameter, right? It's the center, so it's in the middle. And the way you find the midpoint is you just find the average of the x coordinates and the average of the y coordinates. So 3 plus 9 is 12, divided by 2 is 6, and 2 plus 10 is 12, divided by 2 is 6. So obviously they should be the same because they're both a. So that tells us that a is 6. All right. Now what we need is the radius. So we could use the equation, but really the radius is just the distance from the center to either endpoint. I'm going to choose this one. And I'm also going to do this in a way. You could use the distance formula, but let's remember that the distance formula is simply just the distance between 2 points is just drawing a right triangle, right? And finding the hypotenuse of that right triangle. And this side of that right triangle is the difference between the x values. And this side of the right triangle is the difference between the y values. If you do that in the Pythagorean theorem, you will get the distance formula. But the reason that this one is better to do this way is because look at what they do. The distance from 6 to 9 is 3, and the distance from 6 to 10 is 4. So we just have a 3, 4, 5 triangle. All right. So that tells us that the radius is 5. And they want a plus r. So 6 plus 5 is 11. And that is the final answer. Okay. So let's keep going. And take a look at this one. This one is interesting. Here, let me make it a little smaller. Okay. So we have this expression, and it's equivalent to this where A, B, C, and D are whole number constants. All that's telling us is that it does, in fact, factor. If they were not whole number constants, then we wouldn't have rational solutions, and therefore it would not factor. All right. So that's all that's telling us is that this factors. Well, the way that you would factor this is you would do the AC method. So you would do the AC method by doing 8 times 145, which is 1,160. And then you would find factors of that add up to K. And if you could find factors of that add up to K, then it would in fact factor. So it says, which of the following could be a value of K? So if we think about the factors of 1,160, the first obvious one is 1 and 1,160. Well, if they were the values that would add up to K, that would be 1,161. So 1,160 is not going to be possible. So we get rid of that. And then we just kind of do this. You want to attack a problem like this where there is guessing and checking is kind of inherent to the problem. Again, unless anybody has a better way, please leave a comment. But the way that I'm going to do it is then I would do 2, right? I would just keep going in 1160. I should know that, but that is 580. Okay, so again, if it's 2 and 580, then I would get 582 here. There's going to be no way I'm going to get actually 580. So we get rid of that answer choice. Um, and then we could say, well, 3 wouldn't work. We could do 4. So 1160 divided by 4 is going to be 290. 5 will work. 1160 divided by 5 is 232. Well, here, now look at this. If it's 5 and 232, they both would be positive, so the K would be 237. 227 doesn't really look like it's going to work. Um, you could keep checking, but eventually you are going to realize that 10 and 1 whoops, 116, my bad. 10 and 116 are going to add to 126. So we kind of eliminate this as well. I'm curious if anybody has a faster way of doing it. I would run through these pretty quickly and realize that these three can happen, and then this would be the answer, or you just would find this. This is also one that might be easy to find. If you think about this, it's divisible by 10. So it's just 10 and 116 would be 126. Either way, it's some sort of understanding of how the AC method works for factoring, and that this kind of fancy sentence here is just another way of them saying that this thing does factor. Okay. All right. Number three. So we have this expression, these two things are equivalent. So that means I am simply just going to write them as being equal to each other. And this one, actually, nah, let's do it this way. So the first thing is I don't want this fourth root here, so I'm going to get rid of that by raising everything to the fourth power. So that means I'm going to have a to the x, b to the y, and zero point 0.5 times 4 is 2. And then I'm just going to have a to the y, b to the x. And then I'm going to get a to the 2x, b to the 2y equals a to the y, b to the x. So those things I think are logically our first couple steps. And then we really look at the problem further and we say, we want to get a to the 2x minus y. Well, the reason that I would get a 2x minus y is if I divided each of these by a to the y, right? Because a to the 2x divided by a to the y is a to the 2x minus y. So we really have to know our exponent laws for that, which means I don't want this b to the 2y here. So when all is said and done, a to the 2x divided by a to the y is a to the 2x minus y. Again, that's why I divided by that. And then over here, I'm going to get b, again, subtract your exponents, x minus 2y. So therefore, the thing that they're asking me to find is equivalent to this. Okay, so again, these ones are kind of tricky to start with, but you have to recognize this is just exponent laws and then just kind of look at what you could do in the beginning. I want to get rid of the fourth root, which will then in turn get rid of this square root, this zero point 0.5 exponent. And then from there, it just kind of logically makes sense once we kind of know like where we're going. All right, and our last challenge problem. So we could do this a couple different ways. The one thing we want to do is realize that we can find K pretty quickly. K is the x coordinate of the vertex, and the x coordinate of the vertex is always, these two are the x intercepts. The x coordinate of the vertex is always halfway between the x intercepts, so just the average. So 4 plus 9 over 2. That's really 6.5. Okay. So then I have to decide. Also, I'm not going to do standard form here. Oh, I have to realize that the A in standard form is the same A in vertex form or intercept form. So I have the intercepts and I have the vertex. So I can use either one. Let's try intercept form. So intercept form means I have A times x minus 4 times x minus 9. And again, I just want to know what A is. Well, I get A by plugging in the other point, the point that's not the intercept. So that is 6.5 is the X coordinate and 21.875 is the Y coordinate. So I get 6.5 minus 4, and then I get 6.5 minus 9, And let's remember we have a calculator. So I get 21.875. If you just in the calculator, 6.5 minus 4 is 2.5. So you're going to get 2.5. And then the other one is negative 2.5. So that's negative 6.25. And then divide. So 21.875 divided by negative 6.25. So right, I divide each side by negative 6.25. Whoops. So A ends up being negative 3.5. And that's our answer. All right, you could have done vertex form, y equals a times x minus h squared plus k, and substituted in the vertex and then plugged in either one of these points, and you still would have got a is negative 3.5. All right, so stay away from standard form. Standard form is going to be the hardest one to get it into when you're given this information. You're given the vertex and the intercepts, so either use vertex form or intercept form. All right, let us move on to the lesson. Um, and we are going to do that. If you just give me a second here, I should have had this open already, but I'm going to make sure that I have Desmos open so that I can go to it pretty quickly. Because today is all about Desmos tactics. And it's just basically a lot of the different ways that I could think of that we could use Desmos to really help us on the SAT. So let me go to that. All right, let's move on to the lesson here with our Desmos tactics. So what we're going to do is kind of talk about different ways that we could use Desmos to help us. All right. So obviously you could just solve this straightforward and you have a calculator, so that might be easy for you. But I just want to show you a couple different ways to go about this. All right. So one way to solve this problem. All right. So we have this equation. So now I'm going to go to Desmos. And one way you could do this is you could type the left side, so 42x minus 225, into the first one, and then the right side, 18x plus 309, into the second one. And then what we're going to do is we're just going to find the x coordinate of the intersection. You can see that this is kind of a pain, um, which is it's 22.25. All right. So then we would go back here, and you can see the answer is 22.25. Now, I think that this would probably be easier just to solve it. Subtract 18x, add 225, use a calculator. But again, I just want you to see the options that you have. The more complicated the equation gets, the more likely you might want to use Desmos. All right. So that is one way. I'll explain another way in another problem, but one way is to just put this into the left side, this left side into one part, this into another part of Desmos, and then find the x coordinate of the intersection. Okay, now we look at one with a system of equations. So here's another one. If you want to use Desmos, you are simply just going to put this in exactly as it is. So we will open up Desmos here. And in the first one, I'm going to put 16x plus 4y equals 44. And then in the other one, I'm going to put 6x minus 3y equals 21. I'm going to hit the home to recalibrate it. And look, we have the x value of 3 and the y value of -1 is the intersection. So we jump back here, and what we have is it wants the value of x, so we saw that that was 3. All right, so that's pretty quick, right? So you could do the elimination method here, or you could do substitution. I don't think that would be a good idea, but graphing is typically going to be faster. All right. So if you just graph the system, that'll be it. Now, The questions can get more complicated with systems, especially now they know that you're going to use Desmos. But again, for saving time, just realize that you can do that. All right. You can just plug this into Desmos and it'll give you the answer. And you got to know what you're looking for, the intersection. All right. So now we've got how many solutions. So again, we have to understand what we're looking for. It also depends on how we do it. So what I'm going to do for this problem is I'm going to show you another way. So just to recap, one way to solve an equation is to put the left side into one and the right side into the other, so it graphs two of them, and look for the x coordinate of the intersection. Another option, not saying which one is better or worse, just giving you more options, is to do this. So we jump into Desmos, get rid of these, and do this. Just put it in as is. So I'm going to put 3 times x minus 2 squared plus 5 equals 3x squared plus 12x minus 17. If you do this, this is what happens. You don't get intersections. You are going to get a vertical line representing each solution. All right. That is how it works. If you just plug in the full equation into one of them, you'll get vertical line for each solution. We can look here, we can zoom out and think it's safe to say that there's only one vertical line. This is the actual solution. We don't really care about the actual solution here. We want to know how many solutions. All right. So if you go this route, the key is that you know what you're looking for. So if you plug in the left side into one and the right side into another, you're looking for the x coordinate of the vertex. If you plug the equation directly in, you're looking for a vertical line and just see where that crosses the x-axis, and that is your solution. So again, in this one, it only wanted to know how many solutions there were. So clearly, there was just one solution. All right. Now, another use of Desmos is when it wants the minimum value. So we again just go to Desmos and we're going to recenter this and we're just going to plug it in. So you don't have to do the f of x for this one. So just 4x plus x squared minus 12. And we want the minimum value. Oh, actually, sorry. It says the value of x when f of x is at its minimum. So we just want the x coordinate. So just go down here to the vertex and you see that that's -2. All right. We do have negative b over 2a as an option here, but again, this one's kind of all about Desmos, showing you the different ways that you can use it. And so we just have -2, right? That's another one. Wait, basically, what you have to do, you have to weigh your option of how long is it going to take me to type into Desmos versus how long is it going to take me to do the other way. In this case, it'd be negative b over 2a. Negative b over 2a might be faster here. You just see a -4 over 2 times 1, and that's -2. So that could be quicker for you. But just again, the point of this is to just show you the different ways that you could use Desmos. The reality is the best way to take this test is a combination of Desmos and kind of using the ways, the concepts that you've learned. You also need the concepts when you use Desmos because you got to know what you're looking for. It's not like Desmos just like literally tells you the answer. You have to know what you're looking for. So how many distinct real solutions? All right, so here we have a different type of equation. We have an equation that is equal to 0. So here's a third way to solve an equation. So the first way we had put the left side in and the right side in, find the x coordinate in the intersection. Other way, just put the whole equation in and you look for vertical lines are the solutions where they cross the x-axis. Now here's another one. It's already equal to 0. So here's how I'm going to show you your option to do this one. So what we're going to do is we're not going to type in the whole equation. You could, but we're just going to do 5x squared plus 10x plus 16. And what that's going to do is it's going to graph the parabola. All right. Well, I don't even see it, but we'll try to find it here. There it is. And the way you find the solutions where when it's already equal to zero, it's just the x-intercepts. Well, clearly this doesn't have any x-intercepts. So that's it. There's just no solutions. So this one is one of those that's asking for how many solutions does it have? That would just be zero. All right. So I am not here to tell you which one is best, but that the point of me picking those problems was that's the three ways to solve an equation. All right. When it's equal to zero, just graph the left side and look for the x-intercept of the graph. When it's two equations, like two expressions equal to each other, put each expression in separately, find the x-coordinate in the intersection, or you always have the option, type the entire equation in the way it is and look for the vertical line or lines that where they cross the x-axis, they are the solutions. Okay. So now we get into a little bit higher level problems, I guess, some of these. We want to know which of the following must be true. So what I'm going to do is I'm just going to graph this, and then we'll answer a question based on that graph. So we jump back to Desmos here, and I'm going to just put it in as 7 times 4 to the negative x plus 13. And number one says f of x, which of the following must be true? F of x is bigger than 7. Well, 7 is like right around here. So clearly the function is always going to be bigger than 7. The reality is 13 is the horizontal asymptote, which 13 is bigger than 7. So this function will always be bigger than 7. Then it says f of x is always, which is must be true, less than or equal to 20. Well, 20 is here. Um, and it's clearly above 20, right? It's up here at 30. So only the first one is true. So the answer is 1. It's weird that it says 7 and not 13 because it is always greater than 13 because that's the horizontal asymptote. But if it's always greater than 13, then it's also always greater than 7. So they're kind of like messing with you a little bit logically there. But again, the way that we can know, I mean, you might just know that. Again, the quickest way is to just know this is the horizontal asymptote and it is an exponential decay. If you know that, you don't even need Desmos. You get this immediately. But if you need to, Desmos is there. Number 7. All right, here's the deal. Find the value of x that satisfies the equation. The reason I threw this in here is this is, again, just another equation that we're going to use. I would pretty much always use Desmos to solve radical equations. Radical equations just take a little longer to solve when you have to square both sides, and then you've got to factor and then check for extraneous solutions. So just knowing that going in, I'm typically going to use Desmos to solve a radical equation. So I am simply, this one is already equal to 0. So I am just going to do x square, SQRT is the shortcut for square root, minus x. All I have to do is graph that and find the x-intercept, and boom, I've got 3. All right, so I only put in the side that's not equal to 0, and I know that I'm looking for the x-intercept. All right, so again, you could graph stuff. We all know how to graph stuff, but if you don't know what you're looking for, then that's a problem. Desmos is not going to be your friend. Okay, so the answer must be 3. And there we go. Now, here is one that, again, we could do this a different way, but the point of this office hour and this video is to really use the power of Desmos. All right. So this system has infinite solutions. So here's what I'm going to do. Just going to go to Desmos and do this. I'm going to type this in as is. So x plus 7y equals 5. And then in the other one, I'm going to put ky minus 3x equals negative 15. All right, so anytime you put in a letter that is not x or y, it's going to ask if you want to add a slider, and you definitely do. So sliders can be pretty powerful. The way sliders work is yes, you can slide back and forth, but I don't see the point of doing that. I can just change k. I can make k anything I want. So I'm going to start by making k the first value, -7/3. That's the answer. That's answer choice A. So I'm going to put -7/3. So what it does is it graphs this system as if k were -7/3. And the question is saying the system has infinite solutions. So again, knowing how to use a slider and using Desmos is only useful if you actually know what you're looking for. You have to know the concept. This is not like a cheat. They're not just like giving out Desmos here on the SAT and being like, oh, well, now no one has to know math. If anything, you might have to know it more. Like you have to conceptually understand. You can't just like memorize the elimination method or something. You have to conceptually understand that the reason that you would have infinite solutions is because you would have parallel lines. So clearly, this is wrong. The one solution is the intersection. If these things are obvious to you, then that's awesome. Then you know what I'm talking about. But there are plenty of students that don't understand exactly, all these things that are going on. They know that if I do the elimination method, I'll get a coordinate pair, and that's what the teacher wants me to get. But do they truly understand that the solution to a system is the intersection? And for a linear system to have no solution, that would only happen if you have parallel lines. So then what you want to do is just go through all the answers. Well, that's -7. That's answer choice B. Well, that clearly intersects once. Then I'm going to do -14. That intersects once, so the answer must be D, but just to double check. Now I can see that if I zoom out enough. Oh, my bad. That's my fault. I I was saying parallel lines. This is infinite solutions. This is supposed to be the exact same line. So, my bad. So let's review again. If it's no solution, you will get parallel lines. I mean, technically, these lines are parallel, but they're just the same line. So I really said that incorrectly. You will look for parallel lines when there's no solution. And when it's infinite solution, you will look for the same line. So I'm like zooming out here, and it's the same exact line. Because look, if I get rid of that, I can see. I can toggle back and forth. So I clearly have the same line, which means that the answer is -21. So on these infinite solution, no solution problems, on the linear system problems, if you just make a slider, you can check the answers. Now, you probably still need to know it the other way to do it because if it's an open-ended problem, then I don't know if you're going to necessarily just like guess the answer that would make it the same line, or if it's no solution, if you would just guess the answer that would make it parallel. So you also should know how to kind of like, use the elimination method in a way to figure this out as well. Which I'll go through in another video when I just focus on linear systems. We will talk about that, but this one I want to focus on just how to use Desmos. All right. Okay, number 9. Which of the following could be the value of h of x? All right, well, remember, h of x is the y value. So it's basically saying which one of these could be the value of y, which again might seem a little complicated. So let's just go to Desmos and see what the graph looks like. And that then might help us. All right, so h of x is 2x to the fourth plus 4. All right. So it's saying which of the following could be the value. Well, it's saying could 0? Well, 0 is not a y value here. Neither is 1 and neither is 2, but 4 is. So that's the answer, 4. So 4 is the only possible y value of the answer choices that this graph would go through. All right. So once we throw it into Desmos, it makes it a lot easier. But again, you might know that, okay, x to the fourth is kind of like a parabola in a way. Looks a little bit like a parabola going up, starting at the vertex at the origin. And then it's like vertically stretched by 2 and then up 4. So clearly 4 is the only one that can be. Anything below that, it would never go through. But if you don't know that, then Desmos can really help you. All right. We got another one with a slider. So, all right. So we go negative x squared plus 6x minus k. Put it in exactly as is. Add the slider. And the question is saying which of the, it's saying that this is negative for all values of x. So I'm going to make it 4 because that's answer choice A. Well, this is not negative. Negative would be below the x-axis. So that's wrong. Then I try 6. That's wrong. Then I try 9. That is wrong because it is equal to 0. It's not less than 0. All right. It says it has negative values. It has 0 here. So then when I try the last answer, not 12, I clearly see that that's the answer because that is always negative because it's always below the x-axis. So our answer is going to be 12. All right. So that's a cool way to use a slider as well. All right, number 11. So we've got this graph. It intersects y equals c at exactly 1 point. What's the value of c? Well, here is probably easier if we just kind of, this is what I would think about in my head. You should know that this is an upside down parabola. And if you're going to have, and you should also know that this is a horizontal line. So in order for that to intersect at exactly 1 point, that point, I didn't even draw that very well. That point must be the vertex, and it'd be the y coordinate of the vertex. So essentially, this question is just a fancy way of saying what's the y coordinate of the vertex. So if we know that, then it makes it really quick. Let's just use Desmos. Throw that in there, negative x squared plus 9x minus 100. And I just want the x coordinate of the vertex. So all the way down here, the x coordinate of the vertex is negative 79.75. So look what I can do. Type it in, boom, change it to a fraction for you, negative 319 over 4, which is one of our answers. So another cool thing you can do on Desmos, you can do that as well on your graphing calculator, but that just helps you realize, like, easily change from decimals to fractions. Just click that button over there. And again, knowing these things going into the test, you would be surprised, can significantly increase your score because these little timing things add up pretty quickly and can really allow you to answer some extra questions, especially on that second, hopefully hard section. All right. All right, another one. Let's again, this just wants the absolute value of the product of the solutions. Well, let's throw this into Desmos. Now, there's a reason that I want to go over this one in Desmos. So you have your equation there. I want you to see the what would happen if we did this. So remember to hit the home button a lot there to kind of recenter things for you. So if I do this, 3 over 2 absolute value. I thought that would work. Maybe not. Just use that one. Look what happens if I do 4a plus 4 minus 4 equals 20. You see this little like exclamation? It says we only support implicit equations of x and y. So if you're solving an equation that is not x, make it x. So just change it to x. Now I get my two solutions. Look, again, your solutions are your vertical lines. So we can see that one solution is negative 5 and the other solution is 3. So that's the two solutions, negative 5 and 3. And we go back here. So if our solutions are x and y are the separate solutions, so that's negative 5 and 3. And if I multiply them together and take the absolute value, that should be positive 15. Okay. All right, so the takeaway there is when you want it to solve an equation, just make sure it's an x. So just change the variable to x. It gets confusing though, because then they use x as one of the solutions and y. They do a lot of things to kind of like mess with your brain here. So put in x. It's just saying take the two solutions, multiply them, take the absolute value. All right, moving on here. All right. Here we have another one, but again, we have another way to do this, but I want to show you the Desmos way. So if one of the zeros is 8, what's the value of A? So that what that means is we have to know that zeros are the same as x-intercepts. So if I graph this, the x-intercept should be 8. So let's do that. So again, I am going to put ax squared minus 24x minus 64. And then I'm going to add the slider. And again, all this means nothing if you don't know what you're looking for. So if I put my first answer choice of 2, if A is 2, is 8 a 0? Well, is 8 an x-intercept? No. So that's wrong. Then when I change it to 4, well, boom, 8 is an x-intercept. So the answer is A equals 4. All right, we are moving along here. All right. So here we've got which is true when f of x is compared to the graph of g of x. So we're really trying to figure out which direction things are going. So let's use Desmos. And let's look at most of the answers are saying that f of x is a horizontal shift of the graph of g of x to the right and up. So we're really starting at g of x and going to f of x when we look at this. All right. So that's really important that we look at which one we're looking at in relation to the other. So this is talking about f of x being a shift of g of x. So I'm actually going to put g of x in first. And this time I am going to use g of x. Normally I wouldn't, but I think I will here just to keep track of them. So I'm going to say g of x equals root 4x. So sqrt 4x. All right, the next one I'm going to do f of x equals sqrt. We're going to do 4x minus 8 plus 5. So look at this point. 0, 0. Well, where did that go? That went to 2, 5. All right. That's the key, right? So if it went 0, 0 went to 2, 5, that's right 2 up 5, which is C. F of X is right 2 up 5. All right. And the reason is if some of you are wondering why, oh, I thought it would be 8, it's because that 4 has to be factored out to truly see what the shift is. So it's really shifted right 2 and then up 5. So again, we could get this more quickly if you understand like transformations, but Desmos is a really easy way to just see it. You have to know what you're looking at again, though, because if you look at it the other way, you might think that it was left 2 down 5. So it's all about like the perspective. So we just want to look at that before we graph it. So we graph it, we know exactly what we're looking for, and then we go back and we answer the question. All right, now to our last two problems. All right, so here's another one where again, we could do this, you know, we could do this out. We could definitely find the intersection and the y-intercepts and find the area. But again, let's know what we're looking for. So when we go to Desmos, we can answer it as efficiently as possible. We just want the area of RST. That is this triangle here. All right, so let's remember that. And I'm just going to put in negative x plus 8. This one, I'm just going to throw them in like this, x minus 2. I want the area of this triangle. So what I need is the base. So the base goes from -2 to 8. That is a distance of 10. So the base is 10, and the height is just the x coordinate of the intersection because I'm going this way. The height is the x, so that's 5. So it's 10 by 5, which is 50 divided by 2, and that's 25, right? So let's remember the area of a triangle is 1/2 base times height, which is going to be, so again, what we saw was the base was 10, the height was 5, and 1/2 of base times height is 25. Okay, so again, nice, easy way to use Desmos, but then we still have to know what we're looking for, area of triangle and such. All right, down to our last one. So I think this one, again, rather than typing this whole thing in, if I want to know where something is undefined, I just want to know where the denominator is equal to 0. So that means I just want to plug that into Desmos and find its 0 or x-intercept. So I'm only going to plug in the denominator, right? I'm not plugging in the whole function. I'm going to do 4 and then x minus 1 squared minus 12 times x minus 1 plus 9. And then I just want to know where its x-intercept is. That's going to be where that thing is 0. And then since it's in the denominator, I'll be divided by 0 and it'll be undefined. So that's going to happen here at 2.5. So then I go back here and I say that my answer is simply just 2.5. They'll accept 5 over 2 as well, but we got it in decimal form, which is totally fine. All right, so that brings us to the end. So remember, check us out on TikTok, YouTube. Um, and then remember, we offer, one-on-one SAT math tutoring, and we have digital practice exercises and full-length tests. And call or text, email if you want any more information. And we'll keep putting these videos out every Monday at 6 p.m. on Zoom. Send us an email if you want to sign up. We will just continue to be hosting these every Monday, pretty much every week of the year. All right. Hope that was helpful. See you later.